Okay, so where we left off, we're going into step 5 of this hypothesis test, and step 5 is our conclusion, where we state our conclusion. Now, whenever you state your conclusion, especially, well, it's just a really good reference. The hypothesis test flowchart that I attached to my Labs Plus. Um, well, yeah, I attached a PDF. And anyways, the first step of the flowchart is does the original claim contain the condition of equality? So the original claim is where we determined the sign for the alternative hypothesis. We determined that's a greater than sign. So we can use that here. Note, and I'll read that claim again. Is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms? Um, so notice it says more than. That's not equality. That's an inequality. So you would say no for the first step of the flowchart. No, the original claim does not contain equality. So in that case, we would go down on the first step of the flowchart. The second step is, do you reject H naught? This one's pretty straightforward. And this, in step 4, remember that we failed to reject H naught. Since we failed to reject H naught, we are not rejecting H naught, so no again. So we have a no and a no from the flowchart. No, no. So that gives us the fourth option for the wording of the final conclusion. So step 5 is the conclusion, and that wording should be, there is not, I'm just reading directly from the flowchart, there is not sufficient evidence there is not sufficient evidence, or sorry, missed a word, sufficient sample evidence to support the claim that, and then it says ... original claim, if you read that last step of the flowchart. So now, at this point, we just need to pretty much copy and paste the original claim right in here for the remaining part of the sentence. So the original claim is the claim that more than, we would just go directly to that sentence, and we would go to more than 1.9% of Lipitor. This is directly from the problem in the middle of that sentence where it states the claim. The Lipitor users experience flu-like symptoms as a side effect. And this is kind of up to you, but I really like this where you mention at what level of significance. And so a side effect at the, we're going to just explain how picky we were, alpha equals 0.01 level of significance. Okay. So there is not sufficient sample evidence. And since there's not sufficient sample evidence, if you look up the definition of if it's statistically significant, is another way of saying it. It is not statistically significant, so there's not sufficient sample evidence. And so that's telling you that you are in the middle of the distribution, and of the bell curve, and that's in the fail to reject region. So whenever you have a fail to reject, you say there is not sufficient evidence. So if you read the second option of the wording, where the other fail to reject, it also says there is not sufficient evidence. But the wording's different because the first step, if we would have said yes here, it would set up the wording so that we are addressing inequality in our claim, because we want to copy and paste our claim right in there at the end of the sentence. And what we're prepared for is not equality. So that kind of changes the wording a little bit. From the step 2 is there's not sufficient evidence to warrant rejection. And here we're saying there's not sufficient sample evidence to support the claim. So little difference of wording, but it makes a big difference to make the sentence flow correctly. So it's a really good flow chart. I would suggest using it. I got this from a different book. It just works really well, and I think it's really easy as soon as you get used to it. If you took the class with me last term, then you, Math 243, you're probably used to it already. And anyways, continue using it, and you'll be able to use it all throughout this term. So anyways, yeah, so that is the example of a classical approach. And I really want you to get used to the p-value approach, which is where we're dealing with comparing p-value to alpha in step 3 and 4. And so step 3, you calculate the p-value, and then step 4 is you compare the p-value to alpha. And in this case, just to explain the p-value approach, let's go ahead and do that really quickly. So back to step 3. If we were going to do step 3 p-value approach, we would want to, okay, so we're going to use z0 equals 0.76, and we're going to find a p-value. So that represents the probability of being on the tail compared to our test statistic. So we're going to find the probability that z0, that z is greater than 0.76, which is z0. So kind of a picture of this. So what we have is we have a value of 0.76, and we want to find the probability or the area of all the everything to the right of 0.76. That's one way of saying it is the probability that a z-score is greater than that value, 0.76, because greater than represents the area on the tail. So what we're going to do is we're going to look it up on a z-score table. So that is the probability, or sorry, we can look this direct. Well, we can do 1 minus the probability that z is less than 0.76, since the z-score table gives you the area to the left. And looking this up on the z-score table, let's check it out real quick. We have 0.7764. So we have 1 minus 0.7764. So the area to the right would be the complement of 0.7764, which is 0.2236. So that is the area on this tail, 22.36% of the entire area under the entire curve. So is to the right of 0.76. So there's our p-value. So if we're going to compare our p-value, now what we're interested in is, remember, you want to keep into consideration, I'll just draw a picture again to kind of refresh and see it again. The idea is everything, since we're doing a right tail test, anything to the right is in the rejection region. Reject H0. And anything over here to the left is fail to reject H0. So keeping that same idea as from the classical approach, but thinking a p-value is, okay, so if the p-value approach, if the p-value is further to the left, that means your p-value is increasing, because the area to the right, as we move the z0 to the left, will increase our p-value. So imagine that we have this critical region, or in this case 2.33, the area to the right of 2.33 is alpha. So what we want is, if we're going to be failing to reject, which we already know since we already did the classical approach, but if we have a p-value that is larger, if the p-value is larger than alpha, we then fail to reject, because we would be our value would be in the fail to reject region compared to 2.33. Okay, so that would be the p-value approach, and that would be step 4 when we compare. So hopefully that makes sense. Let me know if it doesn't, but you'll have homework on this where you have to compare the p-value to alpha, or at least calculate the p-value and compare them in some way and determine if you fail to reject or reject based off this information. So there's the p-value approach and the classical approach. They're just different, depends on what you prefer. I will make you do the p-value approach to make sure you understand it and verbally explain it for your final project. So be ready to do that, and let me know if you have any questions on the p-value approach. So as we can see, we are failed to reject since the p-value, 0.2236, is larger than our alpha, 0.01. Okay. So, and then of course we would go to step 5, and it's just the same conclusion. We're done. All right. So 2 different approaches. They're both legit. And every time, if you do the classical approach or p-value approach, you'll always get the same result in regards to fail to reject or reject H0. So they agreed with each other. We were failing to reject in both approaches. Okay. And now let's go ahead and go to an example of a hypothesis testing of mu, of our mean. And let's go ahead and hopefully we don't find another example of a right tail test. Let's let's see here. Yeah, let's go ahead and do problem 15 of section 10.3, the effects of alcohol in the brain. So, all right. So section 10.3 example. So section 10.3, we talk about the effects of alcohol in the brain. So in a study in the American Journal of Psychiatry, researchers wanted to measure the effect of alcohol on the development of hippocampal region of adolescence. Hippocampal, I don't know. The hippocampus is the portion of the brain responsible for long-term memory storage. I might be saying that word wrong, sorry. The researchers randomly selected 12 adolescents with alcohol use disorders. They wanted to determine whether the hippocampal volumes in the alcoholic adolescents were less than the normal volume of 9.02 cubic centimeters. An analysis of the sample data revealed that the hippocampal volume is approximately normal, with X bar equals 8.1 and S equals 0.7. Conduct the appropriate tests at the alpha equals 0.01 level of significance. So as we can see here, let's pull out the information like we did in the last problem. So with a mean test, a hypothesis test for population mean, we have different types of data. We're not given a p-hat. That's a sample statistic based off of a gathered sample for a proportion. In this case, the sample statistics would for mean would be X bar and S. right? The sample mean and sample standard deviation. So we have x bar equals 8.1 and s equals 0.7. And we have alpha, our level of significance, of 0.01. And the other piece of information we need is our sample size that gathered this x bar and s, how we got this information, which is very important, as we know. The researchers randomly selected 12 adolescents, so n equals 12. So it's kind of nice here. It actually says in the problem, the researchers randomly selected, so we got our steps of randomness, just to point that out. But anyways, we have all the numbers that we need. But let's proceed. So here's our checks. We're going to go pretty quick through this because it's not really much different. There's some slight differences. So randomness. Do we have randomness? So it says in the problem, the researchers randomly selected 12 adolescents. So I'll just say randomness check. Now, if you remember from chapter 8, we're not dealing with NP 1 minus P is greater than or equal to 10 because we're not dealing with a proportion. To determine if we have a large enough sample size for this problem, we need at least 30, right? But let's see here. But what's kind of convenient is, remember from the check, either we need n is greater than or equal to 30 if we have a non-normal distribution, or we need any sample size, even 1, 2, 3, up to whatever value you want, 1 to infinity of sample size, and as long as you have the original distribution is normal. So as you can see here in the problem, it says, an analysis of a sample data revealed that the hippocampal volume is approximately normal. It tells us it's normal. So, normal original distribution. It says it in the problem. We found out that our sample data is normal. So that we can assume that our population is normal if our sample is normal. Okay? So our original distribution is normal. So we have a large enough sample size. We actually don't even have to check the sample size because we know we were dealing with a normal distribution, not a non-normal distribution. So we're done with that. And lastly, independence. So as you can see, this is almost identical to the checks for a proportion, and we can assume that each of the 12 adolescents that were randomly selected, each one is independent of each other. So independence, we're going to assume to be true. So we're only assuming this one. So we're assuming independence. This is given to us. They say that it's randomly selected, and we know it is normally distributed. So we don't have to assume these. We know that they're true, but we have to assume independence. Okay? And this is a pretty reasonable assumption, considering it's just, in general, it's always an assumption that you can make, because independence is almost always, it never really failed to be obtained. So let's continue, and now we're ready to do our hypothesis test. So step 1 is our null and alternative. So as mentioned before, we have H naught, always, H1, alternative, colons, mu, because our population parameter, in this case, since we're measuring mean, is mu. We're dealing with mean, not proportion. Okay? And we deal with equality here always. Oh, and one other value that we forgot to pull out of here is our mu sub naught, our claimed value of our proportion. And that being 9.02. Forgot to mention that. So that goes right here, 9.02, 9.02. And now are we dealing with a left, right, or two-tailed test? So we read in the problem, they wanted to determine whether the hippocampal volumes in the alcoholic adolescents were less than the normal volume. Less. Left tail. All right, so read it in the problem and you can determine what you're dealing with. Okay? So there we go. There is our normal. There is our null and alternative hypothesis. Step 2. Now we have alpha. Our level of significance, 0.01. It's given to us in the problem. Step 3. Now this represents the test statistic and all of our calculations involved. So our test statistic, I'll just put TS. Now, if you remember, similar to Chapter 9, we're not following a standard normal distribution. We're not dealing with Z anymore, with a mean, measurement of mean, because we don't know sigma. We know S. So it follows a T distribution. So our test statistic is a T naught. And as you may remember, T naught is equivalent to the comparison, and now we're, like 10.2, we're assuming that our claimed value is correct. So we're centered at 9.02. So that goes right there. So we're comparing it to 9.02, our claimed value. How well does the sample match up to our claimed value? So in this regards, we would want to compare 9.02 to 8.1. And we will get back to that.
How's it looking? See?
Wow, that's good. I like it. Very good.
They're tablecloths. Table placements. That'll work, huh?
Yep.